For example 4, we have a revenue problem. It says last year a theater company had 720 season ticket holders. The manager at the theater company has decided to raise the price of a package of season tickets for the new season to generate more revenue. The current cost is $140. Before raising the price of a package of season tickets, he hired a market research company to gather data on the proposed increase, and they said that for every $5 increase in price, then you'd have about 20 season ticket holders would not renew. So each time it goes up by $5, 20 less season ticket packages are going to be sold. So if he decides that the price increases will be in multiples of $5, then if I have one price increase, I'm taking that $140 and I'm adding $5, which is going to be $145. The number of season ticket holders is going to be 720, and I'm taking away 20 of them, so I have 700. If the revenue is the cost, $145, multiplied by the number sold, 700, then this is going to give me $101,500. If I do 2, then I'm going to take that 140 and I'm going to add 5 twice, or $150. I'm also going to take that 720 and I'm going to subtract 20 twice, which is going to give me 680. $150 times 680 people is going to give me $102,000. Following the same logic, if I do 5 price increases, I'm going to take 140 and I'm going to add 5 times, which is going to give me $165 as the price. I'm also going to take that 720, I'm going to take away 25 times, which is going to leave me with 620 season ticket holders. And 165 times 620 is going to equal $102,300. If I went up 10 times, I'm going to get 140 plus 5 times 10 times. This is going to give me a new price of $190. I'm going to get 720 minus 20 10 times. This is going to give me 520 season ticket holders. And 190 times 520 is going to equal $98,800. Which means that each time, if I took 140 and I added 5 x times, then that means I have to take 720 and minus 20 x times, and the revenue is going to equal 140 plus 5x times 720 minus 20x. If I multiplied this out, this would give me negative 100x squared plus 800x plus 100,800. And that's how I'd solve for my generated revenue. If I'm writing a quadratic function in the form r of x is equal to this, then I would say that r as a function of x is going to equal, we've already solved it here, negative 100x squared plus 800x plus 100,800. If I'm writing a quadratic equation which could be solved to determine the number of $5 increases required to generate 102,000, well then I'm going to replace my revenue with 102,000. But my quadratic is still the same. 100x squared plus 800x plus 100,800. If I'm solving this equation to determine the number of $5 increases, then I'm going to start by saying, well, if I have 102,000 is equal to negative 100x squared plus 800x plus 100,800. I'm going to move everything to the left side of the equation in order to make x squared positive, and to combine the constants. So I'm going to say I have 100 x squared minus 800 x and plus 1200 is equal to 0. At this point, I'm going to divide out the common factor of 100 from everything. X squared minus 8x plus 12 is equal to 0. I can factor this. X minus 6 and x minus 2 is equal to 0, which means that x minus 6 would equal 0, x would equal 6, x minus 2 is equal to 0, x would equal to 2. Either 2 or 6 $5 increases will generate $102,000 in revenue. If I'm determining the cost of a package of season tickets and the number of season ticket holders, if we do this, well, if I'm doing 2 increases, then the cost is going to be 140 plus 5 times 2, or $150. The tickets sold is going to be 720 minus 5 times 2, or 680. If I do 6 increases, then the cost is going to be 140 plus 5 times 6, or $170. The ticket sold is going to be 720 minus 5 times 6, or 600 tickets sold. If I'm going to graph the revenue function to determine the maximum revenue which could be generated and the corresponding cost of a package of ticket holders, then I'm going to say that I'm going to graph my calculator. Y is equal to negative 100 x squared plus 800x plus 100,800, and I'm going to solve for the maximum on my calculator. In this case, I'm going to get a vertex when I solve for the maximum at 4 and 102,400. The max revenue is $102,400. And the ticket cost is 140 plus 5 times 4, or $160 to generate that maximum revenue.